Styrene Butadiene Latex Siam Synthetic Latex Company, Ltd. Discussions. What is latex? Latex characterization. SB latex applications. Health hazard and safe handling information. Q&A. What is latex? Latex is a white, tacky, aqueous suspension of a hydrocarbon polymer occurring naturally in some species of trees, or made synthetically. Made by emulsion polymerization techniques from a range of monomers, styrene, butadiene, acrylates, etc. Low in viscosity, 50% water, 50% polymer, and are easy to pour, mix and pump. Stabilized by ionic forces of repulsion between the particles, and also by the addition of suitable surfactants. Latexes may be destabilized by the following ions, especially multivalent cations Ca2+, Al3+. Shear, mixing, pumping. Freeze, thaw. Heat. Advantages of latex. Low viscosity. It is an advantage to have the polymer in a liquid state for processing by the customer. Aqueous. Latex may be used directly in aqueous formulations. There is no organic solvent to remove flammability, toxicity, environmental etc. Unique manufacturing process, fast reaction, good heat removal due to low viscosity. Polymer. A wide range of polymers are available using various combinations of monomers. E.g., the dried polymer may be a clear, tough rubbery film, which may act as a binder in filled systems. A hard plastic, white powder. A sticky, tacky, adhesive. SB latex compositions. Function, contribution. Styrene. Hardness, strength, stiffness, good aging, high Tg polymer. Butadiene. Softness, flexibility, adhesion, poor aging, low Tg polymer. Water. Continuous phase for emulsion polymerization. Enhances heat removal from reaction. Surfactant. Improve stability of latex. Defoamer. Control foaming tendency of latex under processing or end-use conditions. Antioxidant. Increase usage lifetime of product by reducing rate of oxidation, butadiene polymers. pH control agent. Control pH during polymerization. Adjust pH after polymerization to provide stripper stability. Adjust pH for customer specification. Biocide. Control bacteria in latex which feed on organics present. Typical SCG-DAO-SB latex properties. Solids content 47 to 54%, specific gravity 1.01 to 1.06, pH 5 to 10, viscosity 50 to 600 millipascals. S surface tension 40 to 65 dynes/cm, styrene content of polymer 40 to 60%, vinyl acid content of polymer 0 to 6%, particle size 0.12 to 0.25 m. Latex characterization. Solid content. The water and other volatile components are evaporated to determine the non-volatile, solid, content of the latex. This solids content reflects the amount of active polymer, additives etc. in the latex. Filter residue. Latex residue is formed from the agglomeration of polymer particles. Latex is passed through a standard sieve, and the dried weight of latex residue per liter of latex is recorded. Fisheye test. The fisheye test is used to measure the film-forming properties of the latex for coating applications. Film continuity may be affected by waxes or silicon-based defoaming materials. Particle size, light scattering. The weighted average particle size is calculated from the measured dissymmetry of light scattering. The dissymmetry is the ratio of the intensity of light scattered at 45 degrees and 135 degrees. The particle size is expressed in angstroms. Latex characterization. Particle size, HDC. Hydrodynamic chromatography, HDC, is a technique used for quantitative determination of particle size and particle size distribution in latex samples. The latex particles are separated via liquid chromatography according to their size. Latex film properties allows certain predictions as to a latex's behavior and properties in end-use applications. Latex film properties include tensile strength, elongation to break, Young's modulus, swell index, gel content, MFFT, TG, composition Bifter. MFFT minimum film formation temperature. Temperature at which a latex will form a continuous film. Estimation of the MFFT is critical to ensure that proper processing and drying conditions are chosen for developing a latex film during end use, e.g. during drying on a paper machine. Latex characterization. TG glass transition temperature. The TG is the temperature at which an amorphous, non-crystalline, material changes from a brittle, glassy material to a flexible, rubbery state, or vice versa. Some end-user important properties of polymers which correlate strongly with TG, tensile strength, percent elongation, flexibility, hand, MFFT. VOCs volatile organic compounds. Measuring VOCs is important to ensure specifications are being met. Determine the level of odoriferous components in the latex. Examples of VOCs that are often measured include styrene, 4-VCH, 4-PCH, alkyl benzenes. Bacteria. What does bacteria do to our latex? Gives a foul odor. Causes deterioration of physical properties. Can cause residue, coagulation. Bacteria control, clean storage tank, clean shipping container, fast turnover. The drying process stage I water evaporation, solids. 50 to 60 to 70%, particles get closer together and viscosity increases. Coalescence, solids. 90 to 95 to 100%, particles force together and coalesce. Film, interdiffusion. Decrease in gas. Permeability. Stage 2. Stage 3. SP latex applications. Paper coating. Carpet backing. Construction. Cansealant. Wood adhesive. Etc. Dow latex is modified styrene butadiene latex made by emulsion polymerization for variety applications such as paper coating, carpet backing, wood adhesive, cansealant and construction application etc. Paper coating. Used as a binder for pigmented coating of paper and paperboard for offset printing. High wet and dry binding power. Good printability. Stiffness. Blister resistance. Fold crack minimization. Carpet backing. Used for carpet secondary backing applications, providing excellent adhesion when either wet or dry. High tuft bind. Excellent filler acceptance. Excellent mechanical stability. Low odor/low VOCs. Contain antioxidant, cement and construction. Specifically designed for use in cement mortars. Improve bonding, tensile and flexural strength. Durability. Improved water resistance. High chloride resistance. Cansealant. Used for concealant and concealing compound. For food and beverage can packaging. Excellent wet and dry adhesion. Comply with FND.A. 175.300. Paper coating. Why is paper coated? To improve the optical properties, gloss, brightness, opacity. To increase the smoothness of the surface. To improve the printability. To bind the pigment particles to each other and to paper. We say that the binder spot welds the pigment particles. Coated paper prints better. Printed uncoated paper. Printed coated paper. Paper coating compositions. Function, contribution. Pigments. Calcium carbonate and clay. Fill voids and contour on the paper, make paper surface smoother, more even ink absorption. Binder, latex, starch. Bind pigment with the paper. Disperse it. Continuous phase for emulsion polymerization. Enhances heat removal from reaction. Insolubilizer. Improves water resistance of the coating, wet pick, for offset printing. Lubricant. Improves runnability, reduces dusting on calendar and slitters, sheeters in finishing. Dye. Adjust color of the coated paper. OBA. Optical brightening agent. Improves brightness of coated paper by adsorbing UV light and re-emitting it as blue light. Makes the paper look brighter and whiter. No. Adjust pH of coating color to range 8 to 9. Typical paper coating formulation. Formulation equals coating color. Ingredient parts. Calcium carbonate 0 to 100. Kaolin clay 0 to 100. Plastic pigments 0 to 8. Total pigments 100. Latex binder 5 to 25. Starch 4. Thickeners 0.2 to 1.0. Lubricants, stearate, 0.5 to 1.0. OBA 0.2 to 1.5. Defoamers 0.1 to 0.3. Crosslinkers, UF, 0.2 to 0.5. Dash. pH 8 to 9. Solids 50 to 75%. Viscosity 500 to 2000 MPa. Coating normally produced in the mill in a batch process, kitchen. Paper can have 1, 2 or 3 layers of coating. Dow supplies. Binder. Hollow plastic pigment. Solid plastic pigment, carpet backing. Carpet segmentation backing type carpet woven tufted needle felt tiles. Auto mats. Synthetic. Grass. Bathroom. Mats. Underlay. Unitary. SB/EVA/VOTS. Full bath. SB. One side. TML/SB. Rubber crumb/. Poo foam. Poo/rubber/SB. SB/PVC/poo. Natural/synthetic. Latex. PVC/bitumen. Unitary. SB. Secondary. Backing. SB. Foam. HSL. Backing type. EcoWorks. Gel. No gel. Bathroom. Mats, tufted carpet construction yarn primary backing latex compound. Secondary. Backing. Tufted carpet latex compound. Objectives. Good frothability and froth stability, coat weight control. Good tuft lock, prevent tufts pulling out. Penetrate the yarn tufts to bind the individual filaments, prevent billing and fuzzing. Good secondary backing adhesion. Prevent edge fraying when the carpet is cut for installation. Good dimensional stability. Add weight. Required stiffness, hand. By addition of other additives, contribute to ignition resistance and conductivity. Carpet latex compound compositions. Function, contribution. Binder, SB latex. Bind yarns with backing, handed feeling. Filler, Coco 3. Give bulk to the latex compound and reduce cost. Dispersing agent. Offsets the forces of attraction between pigment particles. Reduction of energy necessary to separate pigments into discrete particles. Foaming agent. Froth the compound. Foam stabilizer. Prevents the foam collapsing while in the foam bank. Adjust color of the coated paper. Thickener. Increase the viscosity of a latex compound to prevent the filler settling. Prevents the compound from penetrating through to the face or back of the carpet. Tufted carpet compound formulation. Direct coat, DC. Tufted carpet. Lac applicator. Construction. Application of LMC. Deck coverings, anti-corrosive linings, flooring, paving. Bridge deck overlay. Internal and external ship decks. Footbridge decks. Rail wagons. Chemical or machinery plant floors. Septic tanks. Parking structures. Effluent drains. Commercial and industrial floors. Toilet floors, garage. Railway platform, road. Application of LMC. Integral waterproofing, repairing materials, decorative coatings. Concrete roof decks, render wall. Water tanks, swimming pools. Septic tanks, silos. Cement stucco-like coatings. Cement filling compound. Self-leveling cements. Sprayed concrete for repair of concrete structures. Protective coatings for corroded. Reinforcing bars. LMC mix design, 3 to 6 cm thick. Parts by weight. Component: conventional concrete LMC. Cement 1.0 1.0. Sand, 2 ns, less than half a centimeter, 2.6 2.6. Stone, 25 n, less than 1.2 centimeters, 1.75 1.75. Latex/cement 0.15. Water/cement 0.45 0.37. Water reducer none. Air enter. Agent none. Air content 5 to 8%, 3 to 7%. Vary levels. Typical formulation of LMC. Portland cement. Aggregate, 0 to 12 mm. DL 470, 46% solid. Potable water. PC, polymer/cement. WC, water/cement. M3 400 kg 1650 kg 130 kg 62 kg equals 0.15 equals 0.33. LMC model initial mixing latex deposit on cement and aggregate. Unhydrated cement. Latex. Aggregates. Air. LMC Model 3. Latex close packs around cement and aggregates. Cement partially hydrated. 4. Latex film encapsulates fully hydrated cement. Benefits of DL 470 to concrete. Make concrete stronger and more durable. Improve adhesion, flexural strength and tensile strength with no loss of compressive strength. Impermeability. Reduce penetration of moisture and corrosive chemicals. Abrasion resistance. High traffic area, for example car park. Benefits of DL 470 to concrete, coat. Thinner overlay. Allow less material to be placed to assure protection. Freeze/thaw stability. Improve resistance to moisture penetration and cracking. Workability. Reduce WC ratio, leads to higher density structure. Effective bridge deck corrosion. Financial costs. Traffic delays. Lost productivity. Increased emission. Auto accident. Personal injury. Health hazard and safe handling information. Health hazard information. Inhalation. No adverse effects are anticipated from inhalation. Ingestion. Single-dose oral toxicity is considered to be low. No hazards anticipated from swallowing small amounts incidental to normal handling operations. Skin short. Single exposure is not likely to cause significant skin irritation. Prolonged or repeated exposure may cause skin irritation. Skin absorption is unlikely due to physical properties. Eye may cause slight transient, temporary, eye irritation. Corneal injury is unlikely. First aid measures. Inhalation. No adverse effects anticipated by this route of exposure. Ingestion. No adverse effects anticipated by this route of exposure incidental to proper industrial handling. Skin wash off in flowing water or shower. Eye irrigate immediately with water for at least 5 minutes. First aid facilities. An eye wash fountain and a general washing facility should be available to the work area. Other information. Never give fluids or induce vomiting if patient is unconscious or is having convulsions. Firefighting measures. Extinguishing media. Water fog or fine spray. Carbon dioxide. Foam. Dry chemical. Unusual fire and explosion hazards. Will not burn until water is evaporated. Flammability. Non-combustible, non-flammable while in emulsion. Dried product will burn in a similar fashion to wood. Hazardous combustion products. Upon burning, the dry product generates stench, black smoke. Spill and disposal. Protect people, protect environment. Wear adequate personal protective equipment. Protect environment. Keep out of sewers, storm drains, surface waters and soil. Clean up, for small spills. Contain and cover with sand, sawdust or absorbent material. Clean up, for large spills. Contain and recover for disposal. If entry to drains or sewers has occurred, system may plug. Flush system with large amounts of water.